Hey guys, how you doing? All right, so today we are going to discuss water pressure and air volume and how it affects us as divers. Okay, and also we're going to talk a little bit about equipment maintenance during and before and after a dive. Okay. All right, this is part of your open water dive training. Okay, this is going to be part of section 1. Okay, great. All right, so we're going to start off with water pressure and how air volume affects us underwater and stuff. Okay, so the depth and pressure. Right now, you are under pressure exerted by the air in the atmosphere that surrounds you. Yeah. It's actually the weight of the air. At sea level, the pressure is fairly uniform and expressed as 1 bar or 1 atmosphere. That's in the imperial system. Okay, so we're going to refer to everything in this lecture with 1 bar. Okay, so underwater, you're under more pressure because water also has a weight, which combines with the atmosphere's weight, which is pressure. Okay, because water is much denser and heavier than air, 10 meters exerts the same pressure as one whole atmosphere. Okay? Good. Okay. Therefore, the pressure increases by 1 bar for each 10 meters you descend, which means going down. Yeah? So, likewise, it decreases 1 bar for every 10 meters that you ascend going up. So, at 0 meters, which is sea level, okay, the total pressure is 1 bar. Okay? All right. At 10 meters, the total pressure is 2 bar. At 20 meters, the total pressure is 3 bar. And at 30 meters, the total pressure is 4 bar. Okay? That is, yeah, you got it? All good? Okay, great. Okay, pressure and air volume and density. Okay, water can be compressed, so its volume and density don't change with pressure changes. And since your body tissues are made mostly of water, you don't feel pressure change on most of your body while diving. Yeah. But pressure changes do change the volume and density of the air or other gases that you're diving. Okay, as the pressure increases, as you go deeper, the gas volume decreases because the gas molecules get compressed. The gas density increases because all the molecules are there, but they are packed into a smaller area. Okay, this is one of the most important principles you learn as a diver. Okay, because as a diver, it affects all the air spaces in or in contact with your body. These include your ears, your sinuses, which are right over here. Okay, sinuses being inside here, and your nose. Okay, okay, definitely our lungs, our mask, and when using one, a dry suit. However, diving here in Myanmar is the water is very, very warm, and we will not dive a dry suit, not at all. It's not needed. Okay, so moving on. Okay, you'll also learn that this principle affects controlling your buoyancy, how long your air supply lasts, and some important safety rules. Okay. Air volume and density change proportionately with pressure. This means if you go from the surface to 10 meters, you double the pressure to 2 bar. A given air volume halves, okay, and its density doubles. If you go to 20 meters, the pressure is 3 bar. Okay, 1 air plus 2 water. Okay, awesome. An air volume would be 1/3 the surface volume, and the density would triple. All right. So again, at 0 meters, we're at 1 bar of pressure, and the air volume is 1, and the air density is multiplied by 1. Okay, when we go down to 10 meters, we are at 2 bar of pressure, and the air volume is a half of that from the surface, and the air density is multiplied by 2. Okay, at 20 meters, we are at 3 bar of pressure, and the air volume is a 1/3, and the air density is multiplied by 3. Okay, again, and now at 30 meters, we're at 4 bar of pressure. Okay, 1/4 the air volume, and it's multiplied by 4. And again, now we go down to 40 meters. It's the same thing. Is the air pressure is 5 bar. Okay, the air volume is 1/5 of that from the surface, and the air density is multiplied by 5. Okay, all right. So that is a pressure volume density relationship. All right. So here's a nice example. Okay, you start your descent with a balloon. Okay, filled with 3 liters of air. Yeah, at 10 meters, guys, its volume decreases to 1.5 liters. Okay, the density will be doubled. At 20 meters, its volume decreases to 1 liter. Yeah, the density will be tripled. The relationship is the same with any measurement system, gallon, cubic feet, etc., of air or any gas. Got it, everybody? Awesome. Good job. High five. All right. So moving on. This predictable relationship between pressure and air, or gas volume, and density exists with every depth change, whether descending or ascending. For example, suppose you have 1 liter of air at 30 meters. What would the volume and density be at the surface? Well, let's look at that a little bit closer. The pressure at 30 meters is 4 bar. Okay, that means 3 bar of water plus 1 bar of air. Okay, yeah. The pressure at the surface is 1 bar, so the pressure is 1/4 the pressure at 30 meters. Okay, 1 liter of air brought to the surface from 30 meters, okay, will expand 4 liters at the surface. The air density would be 1/4 the density at 30 meters. Okay, good. All right, so now suppose you fill a balloon completely and seal it at 10 meters. What happens as you go up? That means ascend. What happens? Well, the balloon expands and it grows larger and larger and larger until it stretches past the failure point and bursts, explodes at the surface. All right, to prevent this, you leave the balloon unsealed and vent some of the expanding air as you're going up. Yeah. So basically, that is our lungs. Our lungs in this example is a balloon. Okay. So if we hold our breath and we go up, our lungs are gonna, just like the balloon, expand, and then explode at the surface. This is called the bends. Most commonly referred to as the bends. Okay, your lungs actually don't explode. It's actually the term of part of a lung overexpansion injury. Okay, and this is air embolism, or decompression sickness. Air embolism is when you hold your breath, okay, and the air comes out, the air in the tank that you're breathing comes out of solution, and it forms a tiny bubble in your bloodstream, and that also expands, blocking circulation at the surface. Okay, when you get there, and then you go unconscious. But we'll talk about that more later. Okay. Good. Okay, moving on. Some water. A lot of talking. Okay, great. So here we go. If you don't adjust for increasing pressure, compressing your body air spaces, you can get a squeeze. A squeeze is caused by discomfort, okay, and can cause injury by pressure imbalance that pushes tissues into an airspace. This happens because there is a greater pressure outside the airspace than inside it. Okay, discomfort in the ears as you descend, which means going down, okay, is from an ear squeeze, as we call it, an ear squeeze. It is caused by pressure pushing your eardrum and surrounding tissues inward. Okay, a pulling or sucking sensation on your face is from a mask squeeze. Okay, the mask squeeze. Discomfort in your cheeks, central forehead, and along the nose is from a sinus squeeze. Okay, other squeezes are possible but not common. Okay, so equalization. You can easily prevent squeezes. Okay, by doing this, you just add small amounts of air to your air spaces as you descend. Okay, this keeps the pressure equal with the outside pressure, so they stay at the normal volume. Okay, this is called equalization. To equalize your ears and sinuses, okay, you pinch your nose and blow gently against it, like this. Yeah? Okay, this sends air from your throat, right here, okay, air from your throat into your ears and sinuses. So basically, it'll send air from here, pushing out through your ears, and also you'll feel it in here. And that'll equalize that pressure. Okay. Some people find that wiggling their jaw from side to side and swallowing also works. So you could also do this and swallow, okay? Sometimes that'll work as well, okay? So we're gonna have to equalize early and often, like every 1 meter, okay, as we're diving, okay, throughout the dive, the entire time, okay, as we're going down. When we're going up, there's no need to equalize because that pressure is releasing, okay, and all of the expanding air goes out. But sometimes, if you dive with a cold, which is a big no-no, sometimes when we're going up, that expanding air that's trying to release out of our ears and sinuses, it'll get blocked by that congestion, okay, that we have if we have a cold. And then we'll feel a squeeze as we're going up, and that is referred to as a reverse block. So it's easily to avoid. If you happen to have a cold or an allergy, congestion or something like that, just do not dive. Okay, wait till you feel better and then continue diving then. Okay, but if you happen to dive with the cold, and that does happen underwater, not a problem. Okay, you just stop your ascent, you go down a little bit where the pressure is greater, and then that'll equalize your air spaces inside there, and then you just wait until the pain is gone, and then you go up a little bit. You know, it might take you some time to get up to the surface, doing this technique. All right, so you could easily avoid that by not diving with the cold. Got it? Good. Okay, so we'll talk about that here in a moment. Okay, to equalize your mask, you blow into it through your nose as you're going down. Okay, this is why you can't use goggles for scuba diving, because the goggles do not close in your nose. You need a mask that has a nose pocket. Okay, yeah. Equalize every meter. Okay, before you feel discomfort. Okay, if you wait until you feel discomfort, equalization may be difficult or impossible. Okay, when you equalize as often as you should, you don't feel discomfort or pain at all. Okay, excuse me. Okay. All right, here's a couple little caution signs here. So if you cannot equalize, you stop your descent. Okay, you stop. You signal to your buddy you have an ear problem. Yeah, your buddy or your instructor. Okay, ear problem. Okay, Then we go up a little bit where the pressure is less, and then you're going to try to equalize again. And then once you get it, then you go down a little bit. Remember, always have your fingers on your nose, going down every 1 meter, equalize often. And then you should continue diving. All right, so I'll just read you the deal here. If you cannot equalize, you stop your descent immediately, signal to your buddy or instructor. Okay, if you don't signal, there's no way of somebody knowing that you have any problem. All right, unless you tell them. So signal problem, okay, point your ear, okay, ascend slightly until the discomfort passes and try again. Be patient. After you equalize, descend more slowly, equalizing more frequently. Okay? If you still cannot equalize, you stop and go abort the dive. Get out the water. You might be coming down with a sinus cold or something like that. All right? But if you cannot equalize, you could try these techniques to go up a little bit and try it. But if you still cannot equalize after all of that, no more diving. Okay, you have to go up. Otherwise, you run the risk of losing your hearing for the rest of your life or some serious injuries. Okay? All right. Continuing to descend with unequalized airspaces can lead to serious injuries, like I just mentioned. Ear injuries include fluid accumulation in the middle ear and eardrum rupture. Okay, eardrum rupture underwater can cause severe vertigo, dizziness, and loss of balance, and requires medical treatment. An unequalized mask can cause bruising around your eyes. Okay, also bruising around your eyes, and also broken blood vessels in your eye as well. While it's usually not serious and clears with time, its appearance is dramatic and may be alarming to other people when you look at them with red eyes and stuff, and black eyes, and yeah. Anyways, doctor should be check it out for serious squeezing injuries and complications and stuff. If that does, hopefully it'll never happen to you, but if it does, definitely go to an eye doctor. See if there's any underlying problem in your eyes. Okay, equalize gently. Never attempt a forceful and or extended equalization. All right, so a forceful extended equalization can cause serious permanent injuries to your ears and your hearing. So equalizing should be easy. Okay, nice little, just a tiny little blow against your fingers, and you'll feel this pop in your ear. No problem. All right, so use short, frequent, and gentle equalization techniques. In short, frequent and gentle equalizations do not work. You stop your descent, signal to your buddy or your instructor to ascend a little bit and try again. Wait for the discomfort to pass, and then if you get it, then just remember, keep equalizing more often, more frequently, okay, throughout the dive, and you should be fine. Okay, good. So with practice, equalizing becomes easier for most people. All right, never dive with a cold or allergy. They can cause congestion. It might block normal airflow and may make equalization of the body air passages difficult or impossible. Using cold medications is not recommended. They can wear off during the dive and can cause equalization problems as you ascend. Okay, so definitely avoid using any medications. Okay, wait until you're much better and then continue diving. That's better solution. Okay, you never use earplugs while diving. Never. Okay, they create air spaces that you cannot equalize. The exceptions are special ear protectors made specifically for diving, which they do have, but I don't promote that. All right, so never dive with earplugs. Okay. Similarly, a wetsuit hood that seals too tightly against your ear can also act like an earplug. All right. So if you're diving with the hood, momentarily pull it away from your ear so it doesn't act like a suction. Okay. The increasing pressure may affect other body air spaces as you're going down. It's very rare, but an airspace can develop in your teeth even. Okay, if you have fillings causing discomfort in your teeth, if it happens, stop your descent, okay, because you can't equalize your air spaces in your teeth. Okay, see a dentist. Definitely go on the boat or after the dive. Not on the boat, after the dive. If you can go see a dentist and get your, that means you might have a cavity or a loose filling or something like that. So definitely go take care of that, and then you can continue diving. Okay, we won't be discussing a dry suit or using a dry suit, but we'll discuss here briefly. A dry suit holds a layer of air around your body during the dive. Okay, increasing pressure compresses this air inside the suit, but you learn to equalize the space in the PADI dry suit diver course. But we won't be learning about the dry suit here in Myanmar. So we don't have to worry about that. But if you want to take a dry suit course, I could definitely recommend some areas around Southeast Asia where you can do that. All right. Okay, so your lungs are a large airspace, but scuba provides air at the surrounding pressure. So you don't need to do anything special to equalize your lungs other than to breathe normally and continuously. Okay, when skin diving, that means breath hold diving without scuba, okay, your lungs compress as you descend. Okay, but they're designed to do that. Okay, but the only possible concerns are if you were to descend after exhaling completely, or if you were to breath hold dive very deeply, like 60 meters or more. These are unlikely for most divers. So again, with free diving, that means diving with no scuba equipment, just one breath at the surface. That way you could hold your breath. But during scuba diving, that means you're breathing compressed air from a dive cylinder on your back. Okay, then we fall into we fall into an area where we are not allowed to hold our breath because of the risk of getting decompression sickness. Okay, so I just want to mention the difference between breath hold diving and scuba diving. Okay, breath hold diving, you're breathing one big breath of air from the surface at the same atmosphere pressure, at same 1 bar pressure, and we're going down. So the decreasing pressure is as you're going down is equalized in your body airspace because there's just one volume of air, okay, that is at a constant pressure. Okay, with the scuba diving, you're filling up your lungs and you're also exhaling your lungs. So during the dive, there's going to be periods where you have your lungs are full, and then again your lungs are empty. So with the surrounding pressure, that can be a big problem. But as long as you never hold your breath, nothing to worry about. Everything is okay. Awesome. Okay, so moving on. The effects of decreasing pressure on body airspaces. All right, so as you learned, as pressure decreases during ascent, the air expands and the air you added to your body airspaces increases in volume. All right, this expanding air must exit body airspaces. Normally, this happens naturally in your ears, mask, and sinuses. So you don't need to do anything to equalize them as you ascend. Okay. So the most important rule in scuba diving, everybody, is never hold your breath. So expanding air in your lungs is most important. Because scuba supplies air at the surrounding pressure, your lungs are at a normal volume at depth. Yeah. So when ascending, the air in your lungs expands. But this is not a problem when you breathe normally. Your lungs stay at their normal volume because you release expanding air with each exhalation. Okay, so if during ascent you were to hold your breath, okay, blocking your airway or lungs would over expand. Okay, they would be much like a balloon filled and sealed at depth, which expanding air would burst during the ascent. Okay, so never hold your breath. Never hold your breath. Whoa, whoops, sorry. I lost the camera here. Just a moment. Sorry about that, everybody. All right. So, expanding air can cause serious lung overexpansion, which is lung rupture injuries. For this reason, the most important rule in scuba diving is breathe continuously and never ever hold your breath. Never ever hold your breath. Got it? All right. Even slight pressure changes as little as 1 meter, okay, can cause these injuries if you were to ascend holding breath. Okay, so never ever ever hold your breath. Got it. Lung overexpansion injuries are difficult to treat and can cause paralysis and death by forcing air into the bloodstream and the chest cavities. Okay, treatment usually requires recompression. That's being put back under pressure, okay, in a recompression chamber as soon as possible. However, and where we're located, the closest recompression chamber is in Phuket. All right, Phuket. So we have to supply for a diving related emergency. We have to make our way straight away to Phuket, and meanwhile, the victim needs to breathe 100% oxygen to keep the decompression symptoms at bay. Okay. All right, so that's the reason why we have to have 100% oxygen available. All right, however, diving commonly takes place several hours or more from a recompression chamber, so just bear that in mind. Okay, while very serious lung overexpansion injuries are among the easiest to avoid, breathe at all times and never hold your breath. Okay, I can't mention this enough. Never hold your breath. Okay, this rule is so important that at any time your regulator is not in your mouth, you exhale a slow, steady bubble stream so you are not holding your breath. Also, do not dive with lung congestion, which can trap air in the lungs and cause overexpansion injuries. Okay, every time the regulator is not in your mouth underwater, you need to blow bubbles. Okay, like I just mentioned here. Okay, same thing if, yeah, basically that's it. Always blow bubbles, exhale, and, if in your dive career, if you ever see somebody going unconscious underwater or something like that, your airway is open, and then when you go unconscious, your airway is open, so you bring the diver to the surface, okay, and then you provide the rescue techniques and all that stuff, CPR if needed, all that good stuff, okay? But if you happen to go unconscious, your airway is open, which means you're not holding your breath, and you don't run a risk of the decompression sickness. All right. However, if you go up, that means if you ascend to the surface, no faster than 18 meters per minute. Okay, and we'll talk about that later. Okay, good. Well done. Okay, we're going to mention again shortly about the reverse blocks. Okay, a reverse block is a reverse block. Okay, results when expanding air becomes trapped in a body airspace. Okay, reverse blocks can result from using a decongestant to dive with a cold or an allergy. Okay, during the dive, that decongestant might wear off, and the congestion can trap that air in your ears, sinuses. Okay, making it very painful. Okay, to come up. All right. So again, a reverse block can result from using a decongestant to to dive with a cold or allergy. During the dive, the decongestant wears off. Then the congestion traps air in the ears and or sinuses. All right. So the gas forming in the stomach and intestines during a dive can cause discomfort on the ascent if it doesn't pass. Okay, you prevent this by avoiding gas-producing foods prior to the dive and not swallowing air while diving. Okay, earlier you learned that a tooth squeeze is rare but possible. A reverse tooth squeeze is also rare but can result if air seeps into sedentary erosion under a filling during a dive and can't exit fast enough as you ascend. Again, see your dentist if you ever experience such a problem. Okay, if you feel discomfort in any airspace during ascent, immediately slow or stop your ascent. Okay, descend a meter, okay, until the discomfort is gone, and give the trapped air time to work its way out. Ascend more slowly, giving the expanding gas time to exit. If you have severe or frequent reverse blocks, definitely see a doctor, okay, knowledgeable in dive medicine. And get evaluated. All right, good. Okay, we got a little bit more to go, guys, here. Okay, breathing underwater. Okay, because scuba provides air at the surrounding pressure, as you go deeper, each breath takes more air from your scuba cylinder. Therefore, the deeper you are, the faster you use your air. All right, so again, with the pressure, okay, if you're going down to 10 meters, you're at 2 bar of pressure. You're going to breathe your air 1/2 times as faster at 10 meters than you would at the surface. Same thing with 20 meters. You're under 3 bar of pressure, so you're going to go through 1/3 of your air faster at that depth. Okay, 30 meters. You're at 4 bar, so you're going to breathe 4 times faster. And then 40 meters, you're at 5 bar, and you're going to breathe 5 times faster. Okay? All right. Or not breathe faster. You're just going to breathe that amount of volume of air, a larger volume of air, because the surrounding pressure is that much more greater. Okay? Awesome. So how fast you use your airflow follows the pressure-volume relationship, as I just talked about. Okay, again, your air supply lasts 1/2 as long at 10 meters. Okay, then at the surface, your air supply lasts 1/3 as long at 20 meters than at the surface, 1/4 at 30 meters, and so on. Your breathing rate also affects how long your air supply lasts. Okay. You use your air faster when swimming than while stationary. That is a definite. Okay, pressure reduces an air volume by compressing the molecules closer together. Okay, this means that the air gets denser as you go deeper. Denser air is harder to breathe than air at normal surface pressure. The deeper you are, the more energy you use to breathe. Additionally, breathing faster usually significantly uses more energy. Okay, it takes about 4 times the energy to breathe twice as fast. So the deeper you are, the more effort and energy you spend if you breathe fast. All right, therefore, take slow, deep breaths. Breathing slowly and deeply is the most efficient way to breathe while scuba diving. Pace yourself and dive relaxed. To make your air last, save your energy and don't overexert yourself. Avoid getting out of breath underwater. Yeah? Okay. Slow, deep breathing also helps you handle stress and anxiety. Okay. When an emergency or a threat causes anxiety, your body responds by increasing breathing. But the process works both ways to some extent. If you decrease and control your breathing, you help control and manage anxiety. Okay, this helps you deal with problems based on your training instead of emotion. If you're faced with a problem while diving, stop what you're doing, then reducing anxiety by maintaining or restoring slow deep breathing as you handle it. Okay, so you want a very slow, deep exhale, slow. Okay, good. All right, so let's summarize the 4 breathing rules you've learned so far. Okay, so we want, number 1, breathe slowly and never ever hold your breath. Okay, number 2, breathe slowly and deeply. Number 3, do not allow yourself to get winded or out of breath. And number 4, okay, if faced with a problem, stop, reduce anxiety by breathing slowly and deeply. Okay, cool. Awesome. So we are moving on. We only have a little bit more to go, guys, in section 1. And then we will actually we'll stop here after this little section. Okay, so buoyancy and controlling buoyancy. Buoyancy is one of the properties that make diving special. Okay, buoyancy cancels the pull of gravity, allowing you to fly, okay, or feel weightless underwater. Unless you're an astronaut, there's no way to experience this more than a few short seconds. Okay, understanding the basic principles, okay, will definitely help you learn to control and enjoy your buoyancy as a diver. Okay, buoyancy is the upward force of an object in the water. Okay, which is why you feel lighter in the water. Okay, this force is caused by water displacement. Okay, which is displacement means pushed aside by the object. Okay, it is equal to the weight of the water displaced. There are 3 types of buoyancy. Okay, there's positive buoyancy, neutral buoyancy, and negative buoyancy. All right, so let's see. Positive buoyancy is if an object weighs less than the water it displaces, it floats. That is positive buoyancy. Neutral buoyancy is if an object weighs more than the water it displaces, it sinks. Actually, that's negative buoyancy. All right. If an object weighs the same as the water it displaces, it neither floats nor sinks. That is referred to as neutral buoyancy. Okay, so the 3, positive, neutral, and negative buoyancy. All right. Saltwater has dissolved minerals such as salt in the water, so the volume weighs more than fresh water. Okay, because saltwater weighs more, it causes more buoyancy. Okay, more upward force. All else being the same, if you have more buoyancy when diving in the ocean than when diving in fresh water, you'll definitely have to adjust your weighting, okay, in the 2 different types of water that you're diving in. All right, so you'll learn to use 2 pieces of equipment to control your buoyancy: your weight system and your BCD, which means your buoyancy control device. That is the jacket that you wear while diving that holds the tank. Okay, because they are central to your skill as a diver, many divers make their BCD and weight system two of the same. So some of the BCDs that you buy will have weight integrated pockets. If they do not, then you'll have a weight belt. Okay, so the weight belt or your weight system should hold enough weight for you to achieve neutral buoyancy. While you're learning to dive, most dive instructors will like to make their students negatively buoyant. Okay, and then over time and experience and different breathing techniques, you'll learn to fine-tune your buoyancy, and then you'll use less weight to achieve neutral buoyancy. Okay, awesome, good job. All right, so we talked about inhaling increases your air volume, okay, and definitely affects your buoyancy. So displacement and buoyancy. Exhaling decreases your volume in your lungs, and makes you sink. Okay, displacing the water and making you sink. All right, so basically we talked about that. Okay, and that was section 1-5. All right, we're going to briefly touch on the buddy system. Okay, so now that we're learning to be divers, okay, this is referred to a buddy system. Okay, this is one person, this is the other person, and you swim either side by side or back like that. Okay, one by one. All right, so the buddy system now is the best thing to do as a diver. Okay, for one, it's safety. Okay, safety is in numbers. You never want to dive by yourself, because just if something happens, you don't have anybody there to help you. Also, it's more fun to dive with a buddy. Okay, to share your experiences with, conversation above the water about your dive planning. Okay, and also you could remind each other about your dive goals underwater. Maybe you could, hey, look at that. And then the person comes over, and yeah, it's kind of cool. So the buddy system is set up for safety first, and then fun and enjoyment is the secondary consideration. All right, good. So it's practicality, safety, and fun. All right. So you could assist each other before, during, and after the dive. Safety, you could help each other prevent problems and assist each other if there's an emergency. And thirdly, it's fun. Diving is a social activity, and it's rewarding to share what you see with somebody else underwater, all this stuff. Okay, good. Now we're just going to briefly touch on dive equipment and maintenance and general care. Okay, so different pieces of the scuba gear have specific care requirements, but all items have the following steps in common. Okay, so number one, inspect your equipment for proper orientation, wear, and damage before each dive. Okay, don't dive with anything that is not in good working order. Okay, you can take care of some issues such as replacing a mask or a fin strap that looks worn. For major issues such as a problem with your scuba regulator, you'll usually need to have that equipment professionally serviced. All right, so rinse everything thoroughly in clean, fresh water after use in saltwater, chlorinated water, or fresh water with silt or dirt. Allow it to dry out in the sun before storage in a cool, dry place. This is important for keeping your gear reliable and allowing it to give you many years of service. While divers are not a major cause of invasive species problems, thoroughly cleaning your gear also helps reduce accidentally transferring organisms between environments. Okay, so we checked the web for regional information about accidental organism transfer. All right, but normally just rinse everything in fresh water. Okay, avoid leaving your kit exposed to direct sunlight for long periods of time. Okay, normally you want to cover it. You can leave your equipment set up if you're planning to do another dive here shortly, but you definitely want to cover it with something like a blanket or something like that, just to protect your equipment from the direct sunlight. Okay, direct sunlight can bleach out the colors and speeds a deterioration process of some of the materials in the BCD. Okay, some items require periodic professional inspection and overhaul and adjustment. Have these items serviced regularly. Okay, so that means the regulators, okay, once a year after the dive season, we need to get them professionally serviced by a service technician. That's not myself. All right, somebody that is their job is specifically designed to service regulators. Then they'll come out to the island with all of their specialized equipment, and then they'll service the regulators. that means they're going to replace all of the diving hoses, which that's a fairly easy job. But the one that requires specialized training is the first stage. They take it apart piece by piece, clean it professionally, readjust all of the working interior pressure of it all, and also replace all of the, like I said, the hoses and both of the regulators, replace the valves and the diaphragm and all that good stuff. Okay. And all of the O-rings, and anyways, and also the diving cylinders, they need to be visually inspected once a year and hydrostatically tested every 5 years. All right. In good working order, and they have to be inspected by a certified technician. Okay, also not me. Okay, but normally an equipment technician that's able to certify the regulators normally are able to do the inspection on the diving cylinders. Okay, cool, good job everybody. All right, so there's as I mentioned, we have some gear that we've already talked about before, the diving masks. Okay, there's many different styles. You just want to make sure it makes a seal on your face. So you do that by putting it up your face and sucking in through your nose. If the mask sticks on your face, that means it fits properly. All right, so there's we want to have a snorkel. Okay, the snorkel is a tuba where you can just breathe in and out at the surface by using the snorkel, not by breathing on using your tank air. Okay, there's fins. We have the open heel fin that requires a strap. Okay, and then we have the closed heel fin. Okay, which you can wear just with your feet. Okay, you don't have to wear booties. The open heel fin, it requires booties. All right, so we're going to have the closed heel fin. Okay, awesome. We also have the scuba kit, which includes the regulator set as well as the BCD. Okay, so you need to, after every dive, guys, we just rinse everything with fresh water. Okay, also including the inside of the BCD. Okay, we rinse that with fresh water. We put the fresh water inside our power inflator hose. Okay, and then swash it around inside the BCD and then drain it and empty it. When we rinse the regulator system, the first stage comes with the dust cap. We want to replace the dust cap on top of our first stage by screwing it in. And then we can just hand splash some fresh water over the first stage, and then we could submerge the primary and alternate air source and gauges inside freshwater tank. Okay, just quickly rinse that, as well as the mask, fins, snorkel, and the weight system. Rinse all that stuff with fresh water, hang it out to dry, and we're all set. And then once it's all dried up, then we can put it back in our dive shop. Okay, and also we want to make sure we want to rinse all of the salt water away, and definitely sand. We do not want sand in anything. Sand gets in everything and can ruin also everything. So we want to keep the sand to a minimum, especially on the zipper part of the diving bag. All right, so we definitely rinse everything with fresh water, but make sure that we put the dust cap back onto the first stage of our regulator set. Okay, all right, good. All right, guys, so that is section 1 through section 1 1 through 5 of the open water diver course. Okay, the next set, we're going to do the next half of section 1, and then we'll just continue from there. Okay, guys, so until next time, happy happy days, happy diving, and we'll see you on next week. Okay, bye.